we're installing Arch. I've done this before. I had it on my PC before. I just did ArchInstall before, but I'm going to do it manually this time, do a custom install. I have it on my laptop. This is Arch laptop. We're going to do the install on my computer this time. We're going to do a custom install. We're not going to use any ArchInstall. I'm going to try to make this video slightly comprehensive. Maybe just go over certain concepts and things that aren't immediately apparent. So I made some preparations. I wrote down all of basically my plan, assuming nothing goes wrong and there's no issues, on just some paper. That should help. Alright, so the first step is just going to be to get the ISO. You just download it from ArchLinux.org. And then you're going to flash it to a USB with Rufus or Balena Etcher or whatever you use. Maybe if you're already on a Linux distro, you'd use DD. And just the first insight about the Arch ISO, it's not an installer like Windows or Ubuntu. It's a temporary live Linux environment. And it boots from your USB. And there you manually build the live system onto your drive. The USB has a kernel, it has a shell, it has drivers on it. It runs mostly just from RAM. Basically just a live system running. From that live USB, you connect to Wi-Fi. You can partition drives, format drives, partitions, everything. So the ISO drops you into a live environment, and you basically are the installer. Whereas in an installer, if you have a Windows ISO and you put it onto it's a guided program, and it takes your choices and applies it to the drive. It goes through and asks you, what do you want here? This. Whereas Arch Linux, you can do everything yourself. A good analogy I heard is that the ISO is like a mechanic's workshop on a USB. An installer is a mechanic who follows a checklist that you give them. So you basically you're given the mechanic workshop, and you are the mechanic. So you have the freedom to make it really good, but you also have the freedom to really mess it up for yourself. And how you install it's actually pretty cool. You basically you're running a live system, so you have the Linux directory tree. You mount the partition that you want to install Arch at /mount. And then you use the tools that are already on the live system to create your system from the live USB, which I find pretty cool. I'm just identifying my USB by size. You can see it's just the only 62GB block device. So I'm going to boot from this. And this is just the Arch ISO on it. All of these are kind of similar. This one's just a memory test. You got EFI shell, and then this one's just with speech in one. There's a little bit of latency on this. You can see I'm pressing, and then it doesn't really do anything for a second. Do Arch Linux install medium. First thing I'm going to do is I'm going to check my Wi-Fi connection. You can see that my Ethernet adapter is up, so that's a good sign. I'm just going to try pinging. On cfdisk dev/sda. You see I have 260 gigs of free space on this device. Just make it a 260 gigabyte partition, file system, write that. And we're gonna do the same for VME. So we're making this 150 gigabyte free space into a 150 gigabyte Linux file system. Write that. What we just did is took some unallocated space on my NVMe, which I cleared up before, 150 gigabytes, turned it into a partition, and then gave it Linux file system. I think it's ext4. And then on my SATA SSD, I took unallocated space, turned into a partition, and then gave it a Linux file system. So now if I go ls-f, you can see that we have our new partitions. Just ran something to show us the size of each partition. So you can see that on the SATA SSD, which is labeled SDA here, we have SDA3, the partition SDA3, which is 260 gigs. So we know that /dev SDA3 is our 60 gigabyte Linux file system. And then we know that /dev NVMe0 and 1p6 is where we're gonna put our root. We're gonna mount. We want our root partition /mount. We're gonna do that. We're gonna do mount /dev /NVMe0 and 1p6 mount. Failing. Found the error. Basically, I assumed that when I type as a Linux file system, it made it ext4. But it didn't. A rookie mistake. I'm reformatting both the devices right now. I'm going to be able to mount both of them. I'm going to make a directory, mount my SATA SSD partition on. What we're doing is we made a boot file inside of our mount. We're going to mount our EFI partition into that. That's basically just where the bootloader lives. So I'm just identifying it by size. It's on my NVMe and it's just 1 gig. So we're going to mount /dev /NVMe011p1 mount boot. We can actually install Arch onto the root now because we have the partition that I want to install Arch on mounted at /mount. So we're going to use packstrap. Strap is similar to Pacman, which is just the packet manager. What it does is instead of installing packages onto a working system at root, install them onto mount and whatnot in other systems. So we're installing base, which is just the base Arch Linux space, Linux, which is our Linux kernel, Linux firmware, basically just a bunch of stuff that helps your hardware work. Nano, which is our text editor, network manager, which is just kind of self-explanatory, but it's just a network tool. And sudo, which allows you to do root and admin commands while not actually logged in as admin. This could take a minute. I went and got some food while that was downloading. We're gonna do something called generating fstab. Fstab is file system table. Basically just tells user space where to mount what. So the bottom, or in the beginning, we mounted partition 6 of our NVMe at mount. Mount is going to turn to our root. So this is basically going to tell system, our system, time we turn our computer on, we want to mount partition 6 at root, and also your A3 at games, because that's just what I use to keep my games. I keep all my games on my SATA SSD, separate from the operating system. And then also our EFI partition 1 on the NVMe. So this is basically just a table that tells the user space where to mount what. I'm going to enter the system, do that by arch ch root/mount. Basically, it's treating /mount as our root. Do that because a lot of the processes we need and the programs we're going to use require, because we're building from the mount, and a lot of the things we're doing to build require to actually be at the root. So download something, it's going to download something to the root. We want it to download at mount, not actual root of the live ISO. So we're basically turning mount into our root. That makes sense. I feel like I explained that poorly. Okay. First thing we're going to do from the new we've entered our system is we're going to set our system clock, and we're going to set our hardware clock, system time. We're going to set our locale. Locales are basically just the computer interprets things and formats things. Tells your computer how to format things. We're just going to uncomment our locale. Now we're going to generate locales and create the config file for locales. So we're going to do locale gen, then echo lang push EAF8. Now that we're done with the locales, we're going to set our host name. We're just going to echo, I'm putting -CSys to the host name config file. Pretty easy. We're going to edit hosts and just nano editing config files. It's all is good. It's just defining IP as localhost, so it's setting up loopback. Basically just, if you send something to this IP address, it gets sent back to your computer. Pretty simple stuff. We're just going to our local domain. We set our root password. Just do passwd. Right. We're going to create our user now. The M flag just creates a home directory under your user. So that's just helpful. And then this G flag adds you to the group of wheel. The wheel group is just a group of users who can use sudo basically. Just setting your password. Edit the sudo config file. This one's a bit of a weird one. You have to do it in a different way. You can't just nano it. You nano sudo. You do it in this way. You go editor equals nano this sudo. This just allows the members of wheel to use sudo. This is doing, it's telling systemd, which is basically just, it's the first user space program that the kernel starts up. What it does is just manages all like background processes. It's kind of a abstraction definition, but this just tells it to start it every time that you turn on your computer. Start network manager every time you turn on your computer. Oops. Looks like network manager didn't install before. I guess we'll see. Oh my goodness. Right. What we're gonna do now is we're just gonna tell systemd, which is the first user space program that the kernel starts up. It's basically just in charge of all background processes. We're gonna tell systemd with its command line tool, systemctl, start up network manager. Tip for this command is network manager is case sensitive. You have to have capital N, capital M. Now we're going to download CPU microcode. I have a AMD CPU. If you have Intel, it's going to be different than mine. You don't have to look it up. What microcode is. Basically, CPU has very low level instructions. Sometimes there are bugs in those instructions. Instead of giving you a new CPU, manufacturer, in my case AMD, will ship microcode. It can be flashed to it during boot. So that's what we're going to do. Is we're going to install AMD microcode. That looks like I already had AMD microcode. That's nice. We're going to start downloading our bootloader. Basically, when your computer turns on, the UEFI or firmware in your motherboard looks inside a certain partition on your disk called the EFI partition. And within that partition, there exist programs called bootloaders. And bootloaders, their job is to find the operating system and load it into memory. So the bootloader we're going to use is grub. And then we're going to install some tools as well. We're going to go EFI that just allows grub to write to your EFI partition, and then OS Prober. That's just because I have Windows and Kali Linux on this PC as well. So I just want to be able to find my other operating systems and add for each of them. All right. Since we installed OS Prober, we actually need to enable it. It's disabled by default. So we're going to go to grub's config file and find disable OS Prober. And we're just going to uncomment that right up. Here I mentioned inside of the EFI partition, there are bootloaders. Now I have no bootloader inside of my EFI partition. So I'm going to install grub to my EFI partition. How I'm going to do that is I'm going to go grub install and flag target 86. That's your CPU's instruction set. 64-bit EFI dash directory bootloader ID arch. We're going to make config for grub. So we want to be able to see each operating system. When we turn on our computer, we can pick Arch, Windows, Kali. Right. Pretty sure that it found Windows. It's really nice. So now we're basically done. We're going to exit chroot. We're going to unmount everything, and we're going to reboot. Right, here we are. Oopsies. It looks like it's failing to mount /boot, so we're just going to check our file system table. Looks like /boot is pointing to P1, which is correct. I'm going to write down this UUID. It's basically just it's a hexadecimal number, and it just identifies block devices. And I'm going to run lsblk just to make sure that's the right UUID. Looks like that is actually the correct partition. I'm just going to try mounting it manually, if that works. I see the issue. So actually I should have seen that way earlier. So the EFI partition is formatted as VFAT instead of, I think Linux needs exFAT. So I believe my download of the kernel may have failed. Running the long-term support kernel, my modules are different. So I'm gonna go back in and re-download this firmware, everything. We're rooted back into my system. We're just gonna run the install in the packages again. All right, I'm gonna do something I didn't do before. I'm just gonna rebuild the initial RAM file system. I think it might have done it here. There's something init CPO, image generation successful. Initial RAM file system is just a small temporary system to load before your real root file system. It just helps the kernel find and mount your root partition. So I'm gonna do mk init io. Then I'm gonna use the -p flag. And I'm gonna reinstall grub to the EFI partition. All right, I'm gonna exit chroot, unmount everything. Here we are. I saw it, so I'm in now. I think the problem was that I just didn't have what am I talking about, dude? I'm tired. It's like 12 right now. The problem was that the download failed. My modules were different than the kernel, and that was causing it to not understand VFAT, I guess. So here we are. We redid the install, and it worked. Regenerated grub. We're in.